Afternoon, everyone. Welcome to my talk. And this talk is about how hypervisors can be used as a recovery mechanisms in a mixed critical system. So, little bit about the mixed critical systems. Example, automotives, where you have sometimes subsystems where you require to uh, you may be subsystems which require to run high critical workloads or some low critical workloads. So, my name is Paresh Bhagat. Okay, let's wait for some people. Okay, my name is Paresh. I'm from Texas Instrument. And in TI, we follow an upstream first approach. You can find many TIs actively contributing to many projects, all of the projects and more. Well, the second one is mine. And Gyan is unfortunately not here. He was my lead when I was working on hypervisors. So let me share what I've learned. Disclaimer. Yes. So little overview of the contents we'll be discussing today. First is the challenges in critical systems. Second, what are the existing solutions we have. Little bit about the Jailhouse hypervisors. And then how crash and detection recovery can be used by using existing hypervisors. And what are the use case and advantages. So what are the challenges in a mixed critical systems? First is performance. Whatever solution you are using for your system, it should be a low overhead. Second is reliability and uptime. Obviously, your solution system should be reliable and your uptime should be high. Fault isolation, where you don't require your fault from one subsystem to progress to other subsystem. Delayed recovery, which could cause a loss of data, maybe loss of life, and this is actually a very big problem. Selective recovery, where suppose you just want a part of your system to restart and not the whole subsystem. So this is a major problem. And inadequate crash data, where you need maybe after the inmate or some VM has crashed, you need the data to maybe trace or debug it. So what are the existing solutions we have for maybe recovery mechanisms? So we'll go how the boot flow works. So in bootloader, you have watchdog integrations, in U-boot at least. In kernel, panic reboot, timeout, again watchdogs. In user space, you can use any systems to control your applications using systemd, busybox init, syswinit. Again, as a system-wide recovery, you have, again, your hardware and software watchdog timers. So obviously, hypervisor is a big thing you can use as in mixed critical systems. It offers a strong isolations between different subsystems, and it also ensures that your fault does not progress to other subsystems. So in this talk, I will be discussing about Jailhouse. So we started working in this project around 2 years ago. So I see I have Jan here. So hello. So what is Jailhouse? It's a static partitioning hypervisor. Just splits your hardware into multiple partitions. And it does not, it's different from other hypervisors. It does not emulate any resources. It's also based on Linux. So Linux is the one initializing all the components, and then Jailhouse takes over the hardware. So in this diagram, you can see Jailhouse has the control of your memory, cores, and the Linux and the root cell are up. So a little bit about the root cell and the inmate cell. So a root cell, you can run a minimal Linux kernel in it, and which can handle the system initialization and then the management. And your non-root cells could be Linux, maybe RTOS, bare metal. And the thing which is most important is the shared memory part. So so Jailhouse supports IVSHMEM, inter-VM shared memory. So it creates a shared memory region for different VMs to interact with each other, and also the root. So let's discuss how different types of cells actually communicate with the shared memory. So Linux shell can be a root or inmate. So we have a UIO framework. which helps us to helps a user space application to actively communicate your shared memory. You can map it, read write, control the interrupts. So it is actually presented to Linux cell via it is presented to Linux cell as a PCI device /WIO, and also you can also get interrupts. So it's pretty easy, at least for the Linux part. And for the RDOS or bare metal, you can just, in most general cases, you can just directly access the memory region directly. And here's just a code snippet. It's a config file for our cell where you have different regions, and this you define for every other cell which you want to share the memory address, and then those cells can communicate with each other. So let's discuss the crash detection and the recovery part. So first of all, the Linux will handle the initialization part, obviously. So Linux system will be up. You load your Jailhouse hypervisor, and then when the Jailhouse launches, you will launch your other inmate. And when the other inmate is launched, let's assume that it has all the IVSHMEM framework established, and we run a crash test app on both root and inmate. So there are many actually methods to do that, but we have also used a network interface kind of thing. So first, the crash app will crash app will send a doorbell interrupt to your inmate, and it will send an acknowledgement back to root. And you can decide how long are you planning to wait for the interrupt. And if you don't receive that interrupt, you can maybe guess that the system has crashed. So you can, again, shut down the cell, restart the cell. So it's pretty easy, but let's see the use cases of it. So obviously, it's a big thing to use as using a mixed reality systems, where you also need to supervise some bare metal applications. And also, when you use you need to have a crash test analysis and logging. What are the advantages? It's a selective recovery. As you know, if your system, a subsystem has crashed, you don't need the whole system to restart it. You just need a part of the system restarted, and it will actually reduce your minimal downtime. It's scalable. You can have multiple cells as long you have many cores and many different hardware resources. Supplement hardware watchdog, yeah. Isolation. So as I mentioned, it's the Jailhouse does a static partitioning. You can't dynamically allocate the resources. So all the resources are isolated, and if there's a crash, it won't affect the other cells. So only the part of system will be restarted. And OS agnostic, you can run Linux and bare metal, RTOS. So summary. So hypervisor based crash detection is not a replacement, I would say. It's just a powerful addition, because it offers a strict isolation between different domains, and you can recover specific parts of the system. And it's not about just the recovery of the whole cell. You can actually write an application which can detect a specific part of the inmate and not the whole system. So it offers you a fine-grained control over the inmate. So these are some of the references I've added for this paper. And yeah, any feedbacks, any comments? Yes, go ahead.
Is the partitioning static per CPU? So one CPU or core is dedicated to one cell then?
Yeah.
Can you repeat the question?
So he was asking whether a CPU is dedicated to one cell. So I guess you need a minimum of 2 CPUs for Jailhouse to work. Yeah, go ahead. Okay. I should go back. This one, right?
Yes. So
Yeah.
I didn't understand what happens if your app crashes. So is your cell the one who's going to detect that and then the root cell and then relaunch the app? And then what if the root cell crashes? Does Jailhouse then detect that and is able to relaunch the root cell?
Okay, so I'll just repeat the questions. His question was whether if the root cell crashes, what will happen to your whole system. So yeah, if the root cell crashes, you have no way out. But the only solution so this thing is right. You could have a minimal and stable Linux kernel working. And yeah, if the root cell crashes, you can again have watchdog timers. So it will, restart your root cell, and then you can again go back to your inmate and yeah, this flow. Any more questions? Yeah, I guess we still have 5 minutes, so. Yeah, thank you. Jan, if you would like to, I saw you. I just didn't recognize you, but anything you want to add, maybe? Oh, okay. So what will, are you guys still, accepting contributions to Jailhouse? Or?
We are accepting maintainers.
Oh,
Telling us for years.
okay.
So is Jailhouse used in production on Siemens equipment? No?
None of the problem. It used in production, but it's all
Yeah.
also part of the problem.
Yeah, I know at least TI and NXP are still using Jailhouse. I'm not sure about it, but yeah.
There are more.
Okay.
I help to organize that, but someone has to step forward and
Okay.
work on that.
Okay. Thank you all.